Are you ready for more algebra? Today we're going to be checking out section 5.6, graphing linear inequalities in two variables. And this section basically breaks down into three core concepts. So we have one core concept, which is a three-part how to graph a linear inequality. Step one is you want to graph a boundary line for the inequality. Importantly, if you see a strictly less than or strictly greater than, I'm looking over here, then you would use a dashed line. If you have less than or equal to, or if you have greater than or equal to, you're going to use a solid line. There's a really nice visual tell to know which one to use, and that's the underline. Notice how over here for the solid line, the two inequality signs have been underlined. So when you see that underline, that means you want to use a solid line. Now step two here is to test a point that is not on the boundary to determine whether it is a solution to the inequality. And lastly, you want to shade the half plane that contains the solution. So if it turns out that the test point is not a solution, you make sure to shade the side that is not with the test point. And we'll definitely see examples of all three of these when we get going. Now step two, I also gave you a couple of suggestions here, 0, 0, or 1, 0. Those are the 2 points that I like to use as test points because they are easy to compute algebraically. So let's take a look at this first one. It says to tell whether the ordered pair is a solution of the inequality. And I've already highlighted number 2, so we can work on that one. We see that the inequality is x minus y is greater than or equal to 2, and we get an ordered pair 5, 3. Now I don't know about you, but when I see an ordered pair 5, 3 in a linear inequality, I automatically want to substitute that in. So we're going to go ahead and substitute. Now I know the x-coordinate is 5 and the y-coordinate is 3, so I just need to substitute those in the correct place. 5 minus 3 is 2, so I get the resulting inequality 2 is greater than or equal to 2, which is true. So the coordinate 5, 3 is a solution to the linear inequality x minus y is greater than or equal to 2. Now let's go on to question 9 here. I put my 3 steps on top of questions in 7 and 8, so we're not going to do those, but we're going to follow these 3 steps. So the first thing is to graph the boundary line. Now when you graph the boundary line, you replace the inequality with an equal sign. So this turns into x equals 3, and then we got to remember how to graph x equals 3. And that's just the point or the line where all the x coordinates are equal to 3. So notice that this is 3, 4, this is 3, 2 down over here, this is 3, negative 3. So in all those places, the x coordinate is equal to 3. So my solution line should just go through all of those points. Now I'm going to say this a bunch of times, but if you are unsure about graphing, now is a really good time for you to use Desmos to check your work, because the graphing part of the line is not actually part of the assignment. So you grab a Desmos, make sure you're graphing this correct. If you can't graph this correct, then you're kind of not able to access this problem. That's why we use Desmos. Now, since we have our boundary line now, we just need to decide next need to decide if we use a dashed line or a solid line. Well, since the inequality sign doesn't have a line under it, that means I'm going to use a dashed line. So there's my dashed line, and I'm finished with step 1. So I'm going to put a check mark there. Check mark feels really good there. Next, we're going to test a point that's not on the boundary. And I'm always, unless I can't, I'm going to choose 0, 0. Unless 0, 0 is on the boundary, I'm going to always choose 0, 0. So I'm going to choose 0, 0 here. And I'll write the coordinate 0, 0. And I'm going to substitute that into the inequality to see whether or not I get something true or false. And what I get is 0 is greater than 3, which is, of course, false. So 0, 0 is not a solution, and we need to make sure that we clarify that we know that 0, 0 is not a solution. There's only two things that it could be. Either it is a solution or it's not a solution. And now for the last step, when the test point is not a solution, shade the half plane that does not contain the point. So the half plane just refers to the other side of that line that we graphed in part 1. So they call this the half plane. There are two half planes here. So there we go. We have gone ahead and we have done steps 1, 2, and 3. We've got our line. We have our shaded region. So we have successfully graphed. Now the thing about this shaded region is everything here is a solution. So every coordinate is a solution. So you can just try one. I don't know, let's pick this one over here. This is 5, 1. If I substitute 5, 1 into x is greater than 3, then I'll get 5 is greater than equal to 3, which is true. So it is a solution. Okay, so the shaded region is the region where all the points are solutions to the linear inequality. Let's look at 13, and we're going to follow the same idea here. Firstly, we're going to graph the boundary line. So I see this equation here. I'm going to write down the line that goes with that. Basically, replace that inequality with an equal sign. So y equals 3x plus 1. This has a slope of 3 and a y-intercept of 1. Meaning, I put a point at the y-intercept of 1, and I use a 3 slope, which means I go up 3, and I go over 1, and I put another point. Now remember, we're just putting in the lattice points here, and the lattice points are going to help us graph our line. Now I can't go any more in the positive direction or to the right, so I'm going to go to the left now. I'm going to go back 1 and down 3. Put a point, and then back 1 and down 3 again and put another point. So I do want to put as many lattice points on my graph as I can. It helps me see the pattern. It's easier to see the line. And now that I have all the lattice points, I can draw my line. Make a nice line that goes all the way across the graph. And then we need to decide if we're going to use a dashed line or a solid line. And looking at the inequality sign, based on that inequality sign, I'm going to want a dashed line. So just use your eraser and put a few holes in your line. And that takes care of step 1. In step 2, I want to use a test point, and I'm going to use 0, 0 like I almost always will use. And I'm going to substitute that in. So step 2, we're going to say, if y is less than 3x plus 1, we're going to ask, is 0 less than 3 times 0 plus 1? Is that true? Well, let's do some math here. 0, of course, is a number. 3 times 0 is 0. So we can decide now, if we wanted to, is 0 less than 0 plus 1? Or we can do more math and say, is 0 less than 1? And that is true. So my test point is a solution to the curve, or to the inequality. And finally, we need to shade. So when the test point is a solution, shade the half plane that contains the point. So we want to shade the half plane that contains 0, 0. I just want to make sure 0, 0 gets some of that shading, and then shade the rest of that half plane. And that finishes step 3. Ooh, I don't like that check mark. Let's use an actual pen There we go, check mark. So we've done all 3 steps and we have a very nice graph. Now the hardest part here is usually going to be graphing that boundary line. So again, make sure you're using Desmos to check your work. Last problem, number 18. We've got negative 2x plus 3y is greater than 6. Let's graph this using intercepts because this is in standard form. Let's write that. 2x plus 3y is equal to 6. We're finding the boundary, so we change that to an equal sign. The first one I'm going to look for is going to be the x-intercept. So for the x-intercept, y is equal to 0. We're going to write our linear equality. 2x plus 3 multiplied by 0 equals 6. So we're substituting 0 over here for y. And then we're going to do our math on this. 3 times 0 is 0. So 2x is equal to 6. Divide both sides by negative 2, and that gives us x equals negative 3. So we get a point, negative 3, 0, right over here, negative 3, 0. Next, we're going to find our y-intercept. And our y-intercept, x equals 0. So we'll substitute again, negative 2 times 0 plus 3y equals 6. Then we'll do our math. 2 times 0 is 0, so 3y is equal to 6. Divide both sides by 3, and that gets me y equals 2. So we'll put our y-intercept here on the y-axis, and then we'll draw our line. Now I know I'm like a broken record here because I feel like a broken record, but again, if you're having trouble graphing this, make sure you use Desmos. You want to get that line correct. Next, is this a solid line or a dashed line? And you said it, that's a dashed line. So grab your eraser and just start erasing pieces of your line. And we are finished with step 1. Step 2, we're going to go to our boundary, or not to our boundary, to our test point, which is almost always going to be 0, 0. And we're going to test it out. So negative 2 multiplied by 0 plus 3 multiplied by 0, is that greater than 6? 2 times 0 is 0, 3 times 0 is 0. Is 0 bigger than 6? And that's false. Notice how easy the algebra became when I chose 0, 0. And that's the main reason why we choose 0, 0. We're not trying to make life difficult. We're trying to simplify it as much as we can. So 0, 0 is not a solution. And we have done everything that we needed to do for step 2. Now for step 3, we need to shade the part of the graph that is a solution. So if the test point is not a solution, then we're going to shade the half plane that does not contain the point. So the part that doesn't contain the point is right up here. So there we go. We have now shaded the part of the graph that is a solution. And that concludes our video for today. Hopefully you guys learned something, and I will see you next time when we get on with more mathematics.